So data type register, it can hold the value until the next value is stored in this register. And this register is not similar to the hardware register what we are speaking. This has no limitation on the say machine cycle what it is using. It is not using the machine cycle in order to store the data. So that is another one thing, and it is a data type. It is a data type. So this is basically a storage element. It is a storage element which can hold the data for a longer period of time. So up to what time it holds? It holds until the next data is written into it. So if we just observe here, apart from that, they are not the actual hardware registers, what we generally speak. Then apart from that, they do not need any clock signals. In hardware registers, we require it. If I want to store anything in this, so we have something called as data read, data write. So which will be done based on the machine cycle which is there. So if you have seen in your previous few of the semesters, right, you'll be having some diagram which is represented, which is the timing diagram, which will be giving you some information of machine cycle. So if I have to read, then I have to read within the machine cycle what is specified. Or if I have to write, I have to write within the machine cycle which is specified. So that is register is just a data type. It is not the actual register what we are speaking. It is just the data type. It can just hold the value over there. It does not need any clock for storing or reading the data from the register data type. They basically retain their values unless and until new value is available to be stored over there. Or if you want to store some new value in that register, the old value will be retained. So that is what we are looking out in simulation. So this kind of register data types will be helpful when you're going in for simulation kind of thing. So here what happens is values in the registers, you can change it at any time during the simulation process. So you are doing that with the help of the assignment operators what you have. Suppose if I have declared a register as R1. So after some simulations have happened, then at some point you are writing it as R1 is equal to 01, or say you're writing it in 101 or something you are specifying. So this information has to go and sit in the register value. Now what happens is if you have declared and just left it, I have just declared it, but I haven't assigned anything. So in that case, you should have some default value in that. So generally the default value is nothing but the unknown value, that is X. So by default, register stores value of X if nothing is assigned. So that is what is important in register data type. And apart from that, it does not require any driver for its value to be stored or retrieved. So in your hardware, this thing what happens is it basically requires a driver to read and write. But in this case, it doesn't. But one thing to remember is net. What we are speaking, net is nothing but the wire. Now, if you just look at the stuff, so you had some connection like this, wherein we had A, B, and C. So net is nothing but say the wire what we specify, that is the wire data type. So whenever we are specifying wire data type, if I have to drive this wire to logic 0 or logic 1, it all depends on the previous device what is present. So what happens is this one requires a driver to be utilized in order to make it high or low, or else by default it will be in high impedance state. It will be in high impedance state. So that is the change. Therefore, for net, we require a driver, but for register, we do not require a driver. So that is one of the difference between net and register data type. In order to declare a data type of register, we have to use the keyword reg. So reg is a keyword which we have seen in previous few of the slides where we had come across this one. So if I have to declare a register data type, keyword is reg. Default value which is stored in this type of this data type is X. So if I don't initialize anything or if I don't assign anything to the register, by default X, that is unknown, will be present. If I read some data from that, it will be read as unknown. So we had four different levels, right? 0, 1, then that is value set 0, 1, X and Z. So out of these, the X will be stored. So an example we can just observe here, wherein we have reset, which is register data type, which is a register data type, and it has been utilized here. So what you're doing is you are resetting the bit. So this tells that the size is one bit. This is binary, and the value is 0. And the value is 0. So here what we are doing, we are assigning the value to reset. So if here I haven't assigned, so if I try to read the information, reset will be unknown. So it will be read as X, that is unknown. So here we are just putting the value of logic 1 into reset. Now here we are writing something as hash 100, that is 100 time units. We are again resetting it to 0. So we are assigning the reset bit using this assignment operator. So here reset is a reg data type or register data type. So next one, what we have to look out is what is meant by vectors. Now previously in net and reg, you saw that net and reg, we observed that by default actually they are one bit each. They are one bit by default. Now in reset, we assign the value that is reg data type reset. We wrote one bit binary and some 0 or 1. So wherein it was just one bit. So such kind of information, which is just referring to say one bit in this case, is a scalar quantity. Is a scalar representation, not quantity. It's a scalar representation. Then how do I go ahead with the vectors? If I go for more than one bit, right? Say I specify something as say 3 is to 0. So I have say 4 bits. So if I'm using this one over here or any other data type, so that will be classified as vector type. That will be vector type. By default, they are scalar in nature. They are scalar data types. If it is more than one bit, then it will be vector data type. So by default, we have nets and reg data types, which are scalar in nature. So which is actually one bit. Now net and reg, we can declare them as vectors by having more than one bit allocated to them. For example, in reg, right, in previous we had written reg reset. We had written something. So in this one, while assigning, what we can do is I can take 2 bits in binary. It will be as 0, 1. So I'm having 2 bits. So this one is what now? This one turns out to be a vector form. It is still a register data type, but it will be having multiple bits for its representation. So this is what a vector implies. Okay. If it is having more than one bits, we classify it as vectors. So here vectors are declared with some specification, that is say some syntax is provided. So this is how the syntax goes around. That is, you have to specify high number then a low number. That is something like this. You can specify it as like this, wherein this high number, so in this case 3, for this is just an example what I have taken, will be the most significant bit. It will be the most significant bit in the entire vector. Okay, and even I can have the other way around. I can specify a low number and then the high number. But what happens is whatever number you are specifying over here, it will be acting as the MS bit. That is, I'll write it as 0 to 3. So this one will be holding the MS bit location. It will be the MS bit location. Okay. Low number is the MS bit. So here we'll just see an examples also. Now, since we are assigning more than one bit, what happens is we'll be able to access the bits individually. So here, what we specified, for example, we specified as 3 is to 0. So I'll be having 4-bit locations. I'll be having 4-bit locations, so which is 0, 1, 1, 0 something. So if I want to access this thing, it will be like 0, 1, 2, 3. I am just taking a simple example over here. So it will be like 0, 1, 2, and 3. So if I want to access the bit at this position, I can access it directly. That is, bit access is possible. I can address this bit. I can address this bit directly with the help of this index. Okay. And even I can address a set of bits. Say these two bits I want. I want the bits at location 1 and 2. So I can access these two bits even in this case. So if I make use of vectors, bit addressing or parts of the vectors also can be accessed. And if you want to change something, you can change over there. So this is a kind of bit level operation what you have. So in your microcontroller, in you had seen in say for example 8051, you did not have bit level of operations. If you had to change something, so you had some register information in which it had something. If you wanted to change specifically one bit over here, what you have to do is you have to do some logical or arithmetic operation so that only this bit changes its value. Remaining all will be same. So you take another value, you do some ANDing or ORing. So what you do is I want to change this one to 0. So what I do is I AND these two, and so no matter what is, if 0 is there, it will be retained 0. If 1 is there, it will be retained 1. No matter what is the value here, either 0 or 1, I have to make it as 0. Then ANDed with that will be 0. This one will be 1. So remaining three are same. Only this one is different. So this kind of operations had to be utilized in a microcontrollers which is not supported bit level operations. So in this case, I can go directly and access the bits and then operate on those. So here just a few examples of the vectors. So here you can see wire I have specified as A. I haven't specified any size specification over here. So this is what this specifies, that it is a scalar representation. It is in a scalar representation, and by default it is 1. Similarly, I have reg clock. So which is of register data type, and it is also a scalar form. It is also in its scalar form, which consumes 1 bit. Now, if you just look at the others, that is these two. So wire 7 down to, or 7 is to 0, and the name is bus. So here what it is consuming 8 bits, not 1 bit as in the previous case. That is not as is this case. So this one is be a vector. This also is 32-bit, that is 31 is to 0. So these are the three buses which are 32 bits in its width. So hence this is also a vector. Now similarly for register data type, here you can see it is 0 is to 40. 0 is to 40. It is like low to high. It was high to low. So this one will be the MS bit location. So if this I specify, it will be like this. I'll be having the 8 locations. This one when I consider, it will be like 7th bit here. Sorry, sequence if I just specify 7, 6, 5, so on 0. So this one will be the LS bit location. This one will be the MS bit location. Here, if I just see how it will be like 0, 1, so on up to 40. So this is MS bit location. This is the most significant bit, whatever will be following here. This will be the most significant bit which will be present here. So this is what it implies. So no matter what, how you specify, whether high or low, this one always points to the MS bit. This one always points to the MS bit. So this is an example of vector quantity or vector representation. So here we have, we can just observe here what we are doing is bus 7. So what is this doing? It is accessing the bit number 7 of the vector bus. So here you can see that we have bus A. So here how much it is? If I start off, it is 31, 30, so on, somewhere in between 7 and then 0. So this bit I want to access. So this is how I can access it. This is how I can access it. So it is just one bit access. Now next one what we have here, you can see we have in general bus, that is this one. So if I just observe what happens, this if I happen to write, how it will be 7, that is 7, 6, 5, so on, 2, 1, 0. So I have 3 bits over here. Now here what is doing, 2 to 7 I want to access. So it is these 3 bits what I am accessing here. So 3 least significant bits of the vectors are being accessed. Now here you have to remember one thing, that if I specify 0 is to 2, this is not permitted, because what has happened is the significant bit what you have specified is this one, that is 7. So based on this, access has to be done. Now in this case, if I want to access say 0th and 1th, in this case what I do is register, sorry, this one is different. So if I have to access this one, right, what happens is it will be as, it will be in this one. So if I start off with this one, it will be 0, 1, 2, so on up to 40. So if I have to access 39th and 40th bit, that is this part, using this one. So what I'll be doing, I'll be writing reg 39 is to 40. So here what you have, your higher number first, lower number next. Here lower number first, higher number next. So you should always remember how you have specified the sequence. So generally in coding, what you do is you go for one sequence. Otherwise, it will create confusion. So here also you can go for 40 is to 0, unless and until your design mentions it. Design specification is given. Based on that, you can go ahead. So this is just an example. So remember, this is legal, but this is not permitted, because this bus what is there, if you just check over here, it is specified from high to low. So if I have to access a part of the vector, I have to specify high to low only. I cannot go the reverse way. This is one thing. So here we have another thing, what he has accessed, virtual address 0 to 1. So 0 to 1 implies you're starting from the MS bit and accessing the next MS bit. So 2 MS bits you are accessing. So whereas in the other case, it was the significant bits what you are accessing, in least significant bits what you are accessing. Any queries over here?